Hello, this is 3.8, solving systems of equations using inverse matrices. And in this, thought I was ready, I'm not. And in this section, we're going to find the inverse of a 2 by 2 matrix, and we're going to write and solve a matrix equation to solve systems of equations. So let's get directly into our vocabulary. We've got a handful, we've got 6 vocabulary words. We're just going to go through them as we go through the lesson. So our first vocabulary is identity matrix, and this is for multiplication. So basically, it's a square matrix, and when multiplied by another matrix is equal to that same matrix. So we can think of identity as another form of 1. For instance, if we call the identity matrix I, and we say A times I equals I times A, which equals A. That's what we're talking about here. So our symbols, we have matrix A, B, C, D. Then the identity matrix is going to have a bunch of 1s, and through the diagonal, starting from the left corner, and everything else is going to be 0. That is what the identity matrix looks like. And when you multiply it by another matrix, it's going to equal that same matrix because it's equivalent to 1. And since we have the identity matrix of multiplication of real numbers, we're saying any number times 1 is equal to itself. That's exactly what this is, except for matrices. And then we have a square matrix. That's just a matrix with the same number of rows as columns. All right? So we see here, when we multiply it by the identity matrix, it's going to equal to this commutative. It's just going to equal to the original matrix. So first, let's determine whether the matrix in each pair are inverses of each other. Well, so what we're going to do is we're going to multiply these. And now that we know how to put them in our calculator, on example 1, we're going to put matrix A in your calculator first. Then you're going to put these numbers in for matrix B. And then in your calculator, you're going to type in matrix A times matrix B, and you should get 1, 0, 1, 0. So remember, the 1s are in the diagonals, starting from the left-hand corner, and everything else is right. If you get this, then they're inverses. So if you put in your calculator, you're going to get, your answer is not going to be this, it's going to be 0, 0, 0, 0. Is this the identity matrix? No, it's not. So therefore, A and B are not inverses of each other. All right, let's look at example B, 1B. Okay, so put these in your calculator, put F in for, put the values of matrix F in for, you can replace A, and then you can replace B, or you can go down to C and D and put them in. And then you're going to multiply them in your calculator. So remember, you're going to hit, once you enter them, you're going to hit second matrix, and names will be highlighted. You'll click whichever one is first. So if A is first, you hit 1. And then second matrix, and you're going to do the same process, except for you hit 2 for B or whatever you call these matrices. And in this one, we do FG and GF. So in here, we're going to get the product of FG and GF both equal to 1, 1, 0, 0, which means they are inverses of each other. So pause this and try guided practice 1. Now we're going to look at inverse of a 2 by 2. The inverse of a 2 by 2. So what is inverse? That is one inverse matrix. That's when two matrices whose product is equal to the identity. So if they're inverse of each other, remember, think of the multiplicative inverse. That means when 1/2 times its reciprocal 2 over 1, it equals to 1. So the inverse matrix is just when the product of two matrices is equal to the identity matrix. So here, this little box here, this key concept, you need to note it, that you write this down. This is the actual formula to find the inverse of a matrix. Now, what's important, you need to write this down, and I will check for this, that the determinant cannot be equal to 0. So we take the original matrix, find the determinant. As long as it does not equal 0, it has an inverse. If it equals 0, we can stop there because it doesn't have an inverse. So then you're going to take the reciprocal of the determinant as your scalar times, you're going to switch A and D and make C and B their opposites. So let's find the inverse if it exists. Example 2. So first we're going to find the determinant. So the determinant of this particular one is going to be what? -7 minus -10, which is -7 plus 10, which equals 3. So the determinant does exist. So now let's find the determinant. Let's find the inverse. The inverse does exist. So 1 over 3 times, we're going to switch, so -1, 7, and then -2, 5. So this is just a scalar. So the inverse is going to be -1/3, -2/3, 5/3, and 7/3. And how do we know we didn't do bad math? We're going to multiply, this is the inverse right here, multiply it by the original P, which was 7, -5, 2, -1. That was a name, it's P because that's the name they gave this inverse. So this is P to the -1. All right, and when we multiply it and we check it, we should get the identity matrix, which is 1, 1, 0, 0. Right? Let's look at B. 2B. So we have to see if it exists. So -72 minus -72, which is -72 plus 72, which equals 0. The determinant is 0, so the inverse does not exist. You can stop there. So pause the video and do guided practice 2A and 2B. All right, so this gets us back to our last few vocabulary words. Matrix equations. So a matrix equation is simply an equation in which a variable is a matrix. All right, so they've got different parts. There's a coefficient matrix, there's a variable matrix, and there's a constant matrix. All right, we already learned what a coefficient matrix is because we used those in the last section. The coefficient matrix is going to be the coefficients of these variables. Okay, so we first start with writing our systems because we use this for systems equations. So we write the variable, the coefficient matrix, which is just the coefficient. So that would be x plus 2y, 3x minus 6y equal 9, 3. So we write the matrix equation. This is your matrix equation. Now we have to break it down. Write this into matrix A times the variable matrix. Our variables are x, y, so we go left, right, up, down, equals our constant matrix, which is only the constants of the system. So now think of this as solving an equation. When we solve an equation, what's going on here? We write the equation ax equal b, ax equal b. How do we solve for x? We multiply by its reciprocal, which is 1 over a, which is we do it to this side, correct? And we get x equal b over a when we're solving a regular equation. Here, we multiply it by its inverse, right? Because we said anything times its inverse is the identity, which is equivalent to 1. We do that over here. It's still an equation. What you do to one term, you do it to the other term. This just becomes 1x or x. And then we have a to the -1 times b. And that's how we would solve an equation. So let's use it in a real world example. It says Helena stopped for gasoline twice during a car trip. The price of gasoline at the first station where she stopped was $3.75 a gallon. At the second station, the price was $3.50 per gallon. She bought a total of 24.2 gallons of gasoline and spent $88.05. How much did Helena buy at each gas station? So first of all, we have to write our systems. We know X represents the first gas station and Y the second. So X plus Y equals 24.2. That's the number of gallons that she bought at each one of those. She bought a total of 24.2. And then we know the price, so we can say 3.75x plus 3.50y equals 88.05 because that's what she spent between the two. So we write our matrix equation, 3.75, times xy equals 242.805. So what we're going to do is we're going to take a to the negative 1, right? It's going to be what? We have to find that. Does it exist? So we first do 3.50 minus 3.75, and it's 0.25. So it does exist because it equals 0. So our formula is going to be the reciprocal of that as our scalar times, we switch these two positions, 350 and 1, and we change C and D to the opposites. So now that is what a to the negative 1 is. So here's our equation. We're going to multiply both sides by a to the negative 1, which is here and here in red. We know this is going to be the identity times xy, or simply xy. Here, what they did, instead of taking the scalar and multiplying it to the original and then multiplying, they multiplied these two first, and then they multiply, because you can do that in multiplication, and then they multiply the scalar by it. So when you do that, you get 13.4 for x and 10.8 for y. And how do you check? This is a system equation. These are your solutions. You put them back in both the equations and you should get true results. Now you can also check it in your calculator. And how do you do that? You first have to put in this for A and this for B. Then you're going to hit second matrix. You're going to pick 1 for A and hit x to the negative 1 button. You'll see it right here. I don't know, they show it to you. Okay. And then you just pick second matrix and pick B and then hit enter, and you'll get the first one is x, the second one is y, in that order. So pause it and do guided practice number 3. Yes. And then you can stop the video and we'll see you in class.